Welcome to Chapter 7. This chapter is all about vectors, and I can think of no better introduction to vectors than this clip from Despicable Me. So let's start here.
Hey. I'm applying for a new villain loan. Go by the name of Vector. It's a mathematical term, a quantity represented by an arrow with both direction and magnitude. Vector! That's me, because I'm committing crimes with both direction and magnitude. Oh yeah!
So that's it, really. That's what a vector is. A vector is a mathematical term. It's a directed line segment that has both magnitude and direction. So here's a good example right here. We have this line segment. You see the arrow on the end that shows the direction of the line segment. Now, a couple vocab words. The magnitude of the vector is the length of the line segment. This should be nothing new. The length of the line segment, the magnitude, is essentially the r, the radius, the thing you've been calculating for months now. The direction of the vector is made clear with the arrow, and essentially that is your theta. You can draw a line here, and there's your direction, your theta. So a vector has both magnitude r and direction theta. So notice, none of this is new stuff. This is still a right triangle. I can make a right triangle out of this vector. I'm still talking about the length or the radius, and I'm still talking about the angle or the direction. We're just now calling this a vector. Now, there's a lot of different ways you can write vectors. You can write them with bold letters, with this arrow on top. Usually we write it with an arrow on top because you can't really write in bold. As I mentioned, here's our first vector. We're going to call this vector V with endpoints 1, 2, and 4, 6. So we're going from P to Q. Now, here's an important note. While it's true that P and Q completely determine this vector, it's important to note that since vectors are defined in terms of their magnitude and direction, any directed line segment that has the same length and the same direction is considered to be the same vector. So I could take this red vector here, and if I move that vector up and to the left, and I get this vector here that has the same direction, the same length, and the same magnitude, the same angle, those are technically the same vectors. So it doesn't really matter where a vector starts. All that matters is the length or the magnitude and the direction or the angle. Magnitude and direction. So instead of talking about where a vector starts and ends, because that's not important, we instead talk about the vector in terms of its component form. The component form is written like this, where your first number is the x component of the vector, and the second number is the y component of the vector. So you can see up here on this vector, my x component, the x side of the vector, is 3 long, and my y side of the vector, the y component, is 4 long. So that's why we can write this vector like this, 3, 4. So I could take this vector that's 3 and 4 and move it around to anywhere I want, and it's still the same vector. And then instead of parentheses, we use these kind of like pointy brackets to show that it's a vector that goes 3 in the x direction, 4 in the y direction, and that's how we get that vector. So let's try this with example 1. We have a vector. It's going to start at 2, 3. There's point P. And it's going to end at 6, 4. 2, 3, 4, 5, 6. There's point Q. So there's my vector from P to Q. And we want to write it in component form. So let's break it down into its X and its Y. Looks like the X side of this vector is growing by 4, and the Y side of this vector is growing by 1. So in component form, it would be 4, 1. And we use those pointy brackets. The X component, the Y component. And that's how we write a vector in component form. Now that we know how to write these vectors, we can start to combine them in different ways. The first way we're going to talk about is vector addition. So if I want to take two vectors, let's say vector V and vector W, and I want to add them together, you start by taking vector V, and then you line vector W up where vector V ends. That is vector addition. That's how you add two vectors together. So your first vector, and then take your second vector wherever the first one ends, start your second vector there. And then the vector from the starting point of V to the ending point of W, that is what we call vector V plus W. So now that we know geometrically how this works, let's try it. We have two vectors here. We have vector V, which is 3, 4. And then I have vector W, which is a little more specific. It has a starting point and an ending point. So let's do vector W first, since it specifically starts at -3. So there's vector W's starting point. And it ends at -2, 1, 2, 3, 4, 5. So that right there is vector W. And I know vector V is written in component form 3, 4. And what I want to do is add these two vectors together. Now, I know vector V has an X component of 3 and a Y component of 4. And I can put that vector anywhere. It doesn't matter where it starts. It just needs to grow 3 in the X and 4 in the Y direction. And that's vector V. However, if I want to add these together, then I need to start W wherever V ends. So I want V to end here. So if I'm putting that in component form, V should go down 4, because that will give me a Y component of 4. And it should go over 1, 2, 3, because it should have an X component of 3. And there is my vector V. Has an X component of 3, a Y component of 4, and it ends where W starts. So now if I go from where V is starting to where W is ending, that is the vector V plus W. So let's zoom in here and look at what the component form of V plus W is. So make my right triangle. Looks like Here, let's get some of this out of the way so we can see this easier. Oops, too much. Here's my component form of V. Now let's do the component form of V plus W. There we go, much cleaner. So it looks like V plus W goes 1, 2, 3, 4 in the X direction. And it looks like it goes 1, 2 in the Y direction. So vector V plus W, written in component form, was 4, 2. Now, you're probably thinking, Mrs. Johnson, there's got to be an easier way than drawing this out every single time. Well, there actually is. Let's take this answer that we got for V plus W and look at individually vector V and vector W in their component forms. So I have V in its component form, 3, 4. I do need vector W in its component form, so let's find that really quickly. So it looks like vector W grew 1 in the X direction and -2 in the Y direction. So its component form will be 1, -2. By the way, the other way you can get that is adding, or sorry, what am I doing? Is to take the second X value and subtract the first X value. And that will give you the component form. So -2 minus -3. And then to get the Y component, we're taking the second one, 5 minus the first one. 5 minus 7 gives me -2. So instead of drawing it out and looking at the X and Y, you can also just do that mathematically by doing the second value minus the first value. That will give you your component form. Now that I have the component form of V and the component form of W, we can see how we get V plus W. If I take the X components and add them together, that gives me the X component. And if I take my Y components and add them together, that gives me my Y components. So yes, there is a much shorter way than just drawing this. If you want to do vector addition, just add components. And that will give you the exact same answer. So there's your shortcut. With vector addition, just add the different components and you'll be good. Let's talk about 2 quick little things in this video. We can also do vector subtraction. So vector subtraction is where I take my first vector and my second vector and line them up and then look at where they are from end to end. You could also line them up kind of like this. They've made this parallelogram. The short side of this parallelogram is your vector subtraction. The long side is your vector addition. So that's another way you can think of geometrically vector addition and subtraction. However, just like with vector addition, with vector subtraction, you can just subtract the X and Y components and get the exact same thing. So you don't really need to think of it graphically. We can also multiply vectors by a scalar. That changes the magnitude of the vector. it does not change the direction. So if this is V and I want 2V, I'm making the magnitude twice as long, but notice the direction did not change. I can also make it half as long, direction does not change. I can also make it go in the negative direction, but remember, see how that still doesn't change the direction, it's just making it go the opposite direction. So that's our basics of vectors, how we can write them in component form, how we add vectors, and how we subtract and multiply them by a scalar. In the next video, we'll take all this information and do some practice problems with it.